Okay, so I want to go over how you set this machine up here and how you get everything working. I found the easiest way to talk to the TinyG is through Chilipeppr. Now Chilipeppr is a JavaScript fiddle from, if you go to JS Fiddle, you can make all this kind of stuff. But a guy named John Lauer built some interfaces, some GUIs, graphical user interfaces, that'll send G code right to the TinyG. Okay, he's also got it set up for some other things, but you're looking for right here. If you go to chilipeppr.com, that's chilipeppr.com, okay, and you load the TinyG workspace, you will get this. All right. Now, right now, it's not connected to anything, and the first thing you need to do, you won't see this right here. You will see. Let's get the Chilipeppr logo in millimeters. All right, so that's what you'll see is the Chilipeppr logo, and you'll come down here and it'll say download serial port JSON server. Now that's how you're going to connect your computer and create a port to talk to the TinyG. All right, so the first step is plug in your USB cable to your TinyG. Then you're going to power it up. So we're going to turn the switch on our power strip, and that's going to turn on our TinyG. And after you've downloaded the serial port JSON server, you'll find a folder right here. Now, instead of opening the folder each time, if you just right click and say pin to start menu, okay, you can just find that particular thing right here, serial port JSON server, right in the start menu. All right, so we're going to double click it, and you'll see that it found US serial port number 3. Now, if you don't know how to find this, which one it is, COM1 or COM3, you can just try either one. Or if you hit start, right click on my computer, click manage, and then go over here to the device manager, you can look down here at your COM port, drop that down, and you'll see we have a US serial port. If you leave this window up and you shut off your power supply, watch what happens. It'll repopulate that list and it'll say something's missing here. So we've got COM1, LPT1, and COM3 just went away. So what could COM3 be? Let's turn it back on. It repopulates our list, and we know that the TinyG is on a USB serial port COM3. All right, so we've identified that. I'm going to shut that server down and rerun it because I know it's going to cause a problem. So you start the JSON server first and just minimize it, and it shows that it found it. Now, if you don't find COM3, it's not talking to the TinyG. Just take my word for it. Figure out what's wrong, get it identifying the JSON server, and now when you come into Chilipeppr, you're going to come down here, and you're going to there's two tabs here: a port list, okay, and a server list. So you're going to come down here and find this particular one. It says scan your local subnet. Click scan, okay. And it's going to come back and it's going to say find something at a URL, and it's going to say V180 OSPC. Okay, that's the JSON server. So just click on that and it will load up. And you'll notice in this tab right here where it says TinyG, right here, it'll show V108 OSPC. That's the firmware version for the JSON server that we have it there. And you'll notice it gives you two boxes down here. One says USB serial port 3 TinyG. Make sure it's set to 115,200. Okay, and then highlight that box, and it's going to connect. It's going to populate it on top, and you're going to see you start getting information in your buffers, which is right here. And now we're connected to our machine. So at this point, you're going to start configuring things. Now I apologize for taking a video capture of a screen, because I don't have screen capture software on my friend's computer. This isn't my computer, it's my friend's, and it's just an empty box designed to run his CNC machine. So we want to find out if we're talking to that TinyG. One of the easiest ways is to type $$ right down here in this little box under the serial port console, hit enter or go, and it's going to say, hey, there's a bunch of information here. This is your whole log file. It starts right at those $. It tells you the firmware the version, the build, your hardware ID, and some of the information is going to be underneath. So if you make this box wider until all of those settings end up stopping, you can read what each thing is on each line. So we want to go through this line for line with my particular machine with dual Y-axis. It's 1,000 millimeters on the Y and it's 750 on the X. All right, so that's good to know. And also, what's important to know is what pulleys and belts you're using. We're using GT3 belts with the 20-tooth pulleys for the GT3 pulleys, and we're also using it's an 8 millimeter by 2 millimeter pitch threaded rod lead screw for the Z-axis. Okay, and you also need to know how many degree steps your motors are. These are 1.8 degree. Okay, and the rest, I'll post a link to this setup here on my GitHub, so you can find this file dump and you can go through it line for line and you can get a baseline to start from. Okay, but we'll just cover it real quick. Now if you go on also to the Synthetos website, it'll show you some information how you set these things up. All right, now how to change a parameter is pretty simple. Right here in these brackets over here on this left side, it's going to tell you some information. That's a code. Okay, so if I take $FB down here, it's going to tell me what my firmware build is. Okay, it's going to call to that. Each one of the motors 1, 2, 3, and 4. You see this number 1? All of these parameters from here to here are for motor 1, or M1, then M2, M3, M4. So our motor 1 is set up as 0, and 0 equals X. So to set up motor 1 as 0, X, I'm sorry, let me slow down here a little bit. To set up motor 1 as X, okay, you type this code. You'll type $, and you'll look right here where it says what it is, map to axis. We want to map it to the X axis. So it'd be 1 MA equals, okay, and then we're going to find out what axis we want it to be, which is X, and we're going to put 0, and we put enter, and it gives us right down here, map 1 to axis 0, 0 equal X, and it says MM mode, which is millimeter. It says OK. All right, so we've accepted that command, and that's basically how you go in and change your parameters. You find out what line menu it is, what the code is for it. You type $sign in front of it, and then you type equal in front of that, and whatever the actual variable is you want. And we'll go over ours, what we have. All right. Switches. It starts off at switches and stuff. Now there's 2 different types of modes that you can program this in. One is in JSON code, and one is text mode. Right here, we're going to be setting up for enable in text mode. If you get further advanced and you want to do it in JSON, it's like curly brackets in code with commas and stuff. You would type equals 1. So it'd be $EJ equals 1 to be JSON. $EJ equals 0 is text mode. Okay, so we're in text mode. And if we come down here below this, it says junction acceleration is, it's a 1 with 6 zeros, so that is 1 million. Right? Yeah, okay, 1 million. And this chordal tolerance is 0.0100 millimeters. Okay? And you can set your stuff up to be inches or millimeters. We're set up to be in millimeter mode. We have soft limit enabled. What that means is if your machine has a limit switch on the minimum side, the software will control how far it can travel by a software limiting. So we've got that turned on. And now depending on what kind of switches you have for your limit switches, we have these ones are normally closed, which means that if you use a meter across the 2 outside connections on the switch, it's going to be grounded out, and then when you push the button, it opens it up. So it's normally a closed circuit, and then when you interrupt the switch, it's open, and that's best for noise reduction from all of the stepper motors and things like that. So normally closed is recommended. Motor idle timeout, which means that once these, you can set up the motors to, the stepper motors to always be on. They're only on when they move, or they're on for whatever reason. in a configuration later on. But after they're done doing what they're doing, how long is it till they shut off and turn off? 10 seconds is what we have ours set up to. So that would be motor idle timeout is 10 seconds. We're in text mode. I'm not using any of this JSON verbosity, serialized style, text verbosity. Leave all that alone. Queued report, status internal. That's 250 milliseconds. Expand LF to CLF on text. We're not doing that. Echo. Enable flow control. We have our set to 2. Okay, that's $EX equals 2, which is RTS/CTS. Our USB baud rate is 5, which equals 115,200. So to change that, it would be $BAUD equals 5. Okay. Network mode 0, default G-code plane 0, units, G-code units is 1, default coordinate system 1, default G-code path control is 2, default G-code distance mode is 0. Okay, now let's get to the motors. Motor number 1 axis to the X, so that'd be $1MA equals 0. The step angle is 1.8 degrees. Okay, so that would be $1SA as in Sam Alpha equals 1.800. Okay, so that'd be 1.8 degrees. And to find the information what your stepper motor degrees are, look on the back of your stepper motor and it will tell you right there they're 1.8 degrees. Now with our pulley systems, we're using the GT3 pulleys, the M1 travel per revolution, which is the 1TR. If you ever see underscore TR, that's just not identifying the motor. So we're in motor number 1, TR. The travel per revolution is 60,000 millimeters. Okay, on a GT2 belts, that's going to be 40,000. Micro steps is going to be 8. The polarity is normal. Okay, I'm sorry, it's reverse on our X. It's reversed. We had it normal and we were printing upside down on our X. There's a video online that shows what the problem we had. But so our motor polarity is reversed. Power management is 3 when moving. Okay, I had a problem with this where the settings for the Shapeoko inside the Synthetos configuration files says to set it up to 0, and I scratched my head for a while and I had to ask some questions, and it's actually going to be set up for 3 when moving. We're 3. So motor 3, we're going to map it to 1 as well. It's also going to be a Y. It's going to be the same as everything else as before, 1.8 degrees, 60 millimeters. It's going to be 8 micro steps. It's going to be reversed in this case, so it's going to be 1. So they're going to run in parallel together and not fight each other. Power management is going to be 3 when moving. And now we're down to number 4. Let's move it up a little bit to number 4. We're back up here. Motor number 4. Axis, this is going to be 2. This is our Z motor. So motor number 4 is Z for us. Again, it's a 1.8 degree step angle. And since we're using that 8 millimeter diameter by 2 pitch lead screw, it's going to be 8 millimeters for the travels per revolution. However, the micro steps is 4. Okay, I believe I have that right. I don't know if the micro step is supposed to be 2 for an 8x2, but what we have working on our distance, it is set up for 4. So if we got that wrong, guys, I apologize, but this is what's working for us. The polarity on our Z is normal, so that, I'm sorry, the polarity on our number 4 motor is 1. It's reversed. And our power management is 3 when moving. Okay, so after you do motors 1, 2, 3, and 4, you're going to see some letters X, Y, and Z. Okay? And when I say letters inside these brackets, it's going to start with the letter X. And if you see right here, that's the X axis, Y axis, and Z axis. Okay? So starting off with our X axis, we're going to define things like velocities, jerk angles, homing, deviations, and our switches. Whether it's going to be a min switch or a max switch, and what kind of switch is it? A homing, a limit, stuff like that. So this is where we're going to get into our limit switch stuff. A lot of this stuff I didn't figure out. I just followed a guide, so if I'm wrong, I'm wrong. So starting up here on axis mode, it's standard. That's XAM. Under velocity for X, velocity maximum, it's 16,000. Feed rate maximum, 16,000. The travel rate minimum is 0. Now this travel rate maximum, that has to do with our soft serial. I limited our X to 550 millimeters. Yes, we have a 750 millimeter piece of extrusion for X. However, with all of the connections and the width of the carriage and stuff like that, it only allows us from the limit switch over, the home switch over, 550 millimeters of travel. Now the X jerk maximum is 5,000. X jerk homing is 10,000. Junction deviation is 0.0100 millimeter. Now our X switch min is going to be set to homing. So that means we set up a minimum limit switch, and we define that limit switch as a homing switch. So on the 0 side, or the minimum travel, we set up a homing switch. X switch max, we have no max, so we have it set to 0, which is off. Okay. The search velocity is 3,000 millimeters. The latch velocity is 100 millimeters. Latch back off is 20 millimeters. And 0 back off is 3 millimeters. Now we move to the Y. I'm going to move the Y up to right there. In the axis mode of the Y is 1. Velocity, a lot of these parameters are the same. Velocity maximum 16,000. Feed rate 16,000. Travel minimum is 0, so it can go to 0 millimeters. You can set offsets and stuff, and the software will stop it earlier than 0, but we've got it going to 0 for home. And then the Y travel maximum is 760 millimeters. Now we do have 1,000 millimeters of travel on the Y axis. However, if you notice that wiring, it's pretty messy. He hasn't determined how he wants to finalize. I think he's going to mount everything on the wall. And right now, the most he can go without snatching the wires out of the power supplies is 750 millimeters. So that means the machine will home, but the maximum travel the machine limits to is 750 millimeters from the home position. Now don't be fooled. If you start the machine up and it's not in the home position, say you start it up in the middle of the table somewhere, and you tell it to go 750 millimeters, it's going to think it's at 0 at the home position, and it's going to take off and it's going to crash that axis. So make sure that you understand that the soft limits are actually physical from 0 home position, how far it can travel from there, not actually the position of the head when you turn the machine on, because it's not always the same. Home will send it home from wherever it's at on the table till it hits the switches, but 0 is defined when you turn the machine on because everything's set to 0, 0, 0. So that means if your head is all the way up in the middle of the table, those soft limits aren't going to stop it from crashing the long end of your axis. I hope that makes sense to you. Okay, so back to, so we were at 760 max travel. Jerk is 5,000 millimeters. Jerk maximum is 5,000. Jerk homing is 1,000 millimeters. The deviation is 0.0100 millimeters. Y switch minimum, we have again a minimum switch set up, and we set it up for homing on the Y. And the max, we didn't use a switch for the max side of the travel, so we have that turned off. Y search velocity is 3,000. Latch velocity is 100. Latch back off is 20 millimeters. 0 back off is 3 millimeters. And now we're going to the Z mode. All right. So Z axis mode is standard. The velocity maximum is 800 millimeters. It's different than the pulley belt setup. We're using that lead screw, so it's 800 millimeters. The feed rate's 800 millimeters. The Z travel minimum is 0, and the maximum travel we have it set up for 40 millimeters. Now the Z is kind of tricky because 0 changes, home does it. Home is with the head all the way up, and 0 is the tool surface of whatever you're cutting. So setting a soft limit for your Z-axis is kind of tricky. If everything's in a perfect world, you could set it up if you bottomed out your tool every single time at the beginning of your job before you turn on the machine, your soft limit will work. It will only go 40 millimeters. However, if you push home on it, it's going to go all the way up to the top to try to get the tool away from the material. It's going to stop, and if you type go Z 20 millimeters, it's going to try to go past because it's at 0 now, because when you go home, it sets 0 up. Right? So we're still working on that, and I'll update this video on those settings later on after we get that figured out. Again, this is just a starting point for you guys. Alright, so we were at 40 millimeter travel max. Z jerk maximum is 50 millimeters. Z jerk homing is 1,000 millimeters. Z junction deviation is 0.0100 millimeters. Z switch min is 0. We didn't use the minimum this time. We used the max travel because we want the head to go away. So we use a Z max switch. Z max switch is set to 3, which is limit and homing. So if it tries to crash the axis, it's going to hit it and it's going to limit it, right? So that switch is actually a limit switch to prevent it from crashing. However, you'll get a flag. You'll get this, it'll say error flag or something like that. In order to clear the machine, there's a few ways. A, you can come over here and push reset. That'll reset it. You can push the reset button on the TinyG, or you can power cycle everything and reset the machine if you get that flag error. All right. Now, Z search velocity is 3,000. That's the search velocity. The latch velocity is 100. Latch back off is 20 millimeters. Zero back off on the Z is 3 millimeters, and then it goes A, B, and C axis mode. Okay, PWM. There's a PWM frequency that's going to be 5,000. PWM counter clockwise speed low 0. You can run the spindle in clockwise or counterclockwise depending on which code you send it. So the clockwise speed high is set up for 10,000 RPMs. The PWM clockwise phase low is 0. PWM clockwise phase high is 1.0. PWM counterclockwise speed low is 1,000. PWM counterclockwise speed high is 2,000. PWM counterclockwise phase low is 0.125. PWM clockwise phase high is 0.200. And PWM phase off equals 0. Now that will allow you to send some codes to turn on your spindle. For example, if I want to turn the spindle on at 8,000 RPMs, I would type spindle as in S 8,000, then a space, and then I would type M03. That turns the spindle on. Now we're at 8,000 RPMs and the spindle is on. If we want the spindle to be 4,000 RPMs, we could type S 4,000. Now we cut the speed in half, 2,000, and so on. If we want to turn it off, that's M05. Alright, so that's how you run your spindle. So if you don't want to program G-code to turn on your spindle and stuff like that, like if you're using CamBam or actually using JScut and it doesn't turn spindle on or whatever, or you don't put that code in, you can do it in Notepad if you want. You can put this code in wherever you want, and it goes line by line. It does exactly what it says to do. So at the beginning of your cut routine, you type S8000 space M03, spindle will come on, it'll run the G-code, and that when it's completed, you type M05, it shuts the spindle off, and you're good to go. If not, before you push play on your G-code up here, just type S8000 space M03, turn it on, push play, and then use M05 to shut it off when the job's over, okay? That's pretty simple. And then all this other stuff here, after the PWM controls, this G54 through G30C, all of these different G codes, those are offsets. They're all 0. Don't worry about those. So that's it, guys. That's the setup. Let's go ahead and run some stuff in here and play with the machine.